Hi everyone, my name is Zhifei Chen and I'm from Nanjing University. Today I will introduce our work about an empirical study on dynamic typing related practices in Python systems. As you all know, dynamic languages such as Python and JavaScript are becoming popular for their flexibility, and they are increasingly used in critical application domains. One reason for this popularity is that these languages support dynamic typing discipline. For example, require no type declaration, modifying variable types or object structures dynamically. This freedom offered by dynamic languages allows developers to program at a higher level of abstraction. However, recent researchers have discovered that dynamic type systems tend to reduce development productivity, code usability, and code quality. Especially, type errors usually appear in dynamic languages because type checking is very limited. This is an example of dynamic typing related practice in a famous Python system named IPython. You can see in the first statement, module name, its type is dict, but in the last statement, the type is changed from dict to string, which are inconsistent types. In fact, it was reported as a bug by developers because the variable was used as a wrong type in the following code. The problem in this example comes from reusing variables, and the way it is coded makes it hard to understand. As refactoring, you can see module name in the first statement was renamed to API2 module, and in the last statement, the variable name was also changed. So after refactoring, the code is easier to understand. You can find that although dynamic typing related practices benefit the rapid development, some types of them will increase maintenance efforts or even produce bugs. So this study aims to solve some important problems about dynamic typing related practices. First, which dynamic typing related practices are dangerous? We will introduce 6 types of dynamic typing practices in Python programs, which are common but potentially dangerous usage of dynamic typing discipline by developers. Second, how to detect them? We have implemented a tool named PYDYPE to detect such practices. Third, what are the characteristics? Based on PYDYPE, we conduct an empirical study to understand dynamic typing related practices. We investigate how widespread they are, why they are introduced into the systems, whether they are related with bugs, and how developers fix such bugs. Now let's start by introducing 6 types of dynamic typing related practices we started, which are common but potentially dangerous in Python. First, in Python, with the ability of dynamic typing feature, changing types of any first-class object at runtime can introduce misbehavior in a program because types are not stable at all. No compile time warnings are reported if a variable has inconsistent types against the developer's will, so it leads to incorrect behavior due to wrong types. So the first 3 types of dynamic typing related practices we studied are inconsistent typing practices. First one, inconsistent assignment types means one variable is redefined with an inconsistent type. The code fragment we mentioned before is an example of such practice. Similarly, inconsistent argument types and inconsistent variable types mean that one argument or one variable has inconsistent types. So these are about changing variable types dynamically, which may produce bug issues. Another dangerous practice is to change an object structure dynamically, especially container objects, class objects, or instance objects, because the structure of an object is no longer stable and all the variables referring to it are affected. So the next three types are bad practices of changing object structures dynamically. First, dynamic element deletion and dynamic attribute deletion mean one element or one attribute is deleted from an object at runtime. It will cause errors if developers filter the elements or attributes after deletion. Finally, dynamic attribute access means one attribute is visited based on a dynamically determined name. Here is an example in Ansible. This statement gets an attribute value from def, while the attribute name is a variable and undetermined. In fact, it is very dangerous to filter an attribute in an undetermined behavior. A suggested solution is to check the existence of the attribute before getting its value. So in our study, we analyzed the above 6 types of dynamic typing practices. It doesn't mean that they are not allowed to appear in programs, but they should be restricted to avoid errors. Such practices also exist in other languages. We developed a tool named PYDYPE to detect these dynamic typing-related practices. Its input is the source code of the program, and its output is instances of dynamic typing-related practices in the program. The implementation of the detection tool contains 3 main components. The first component, AST parser. AST parser extracts all Python code from the target program and passes them into abstract syntax trees. From the parsed AST, the tool extracts 3 important code entities. These code entities contain the started practices. The second component, type analyzer, uses Pythona and MyPy. There are 2 type inference tools for Python. We compile the results of the 2 tools to infer the types of all variables in the program. Finally, based on the extracted code entities and the inferred types, the third component, practice detector, detects the occurrences of dynamic typing practices by checking type inconsistencies and analyzing AST nodes. So, based on the detection tool, we conduct an empirical study to answer these 4 questions. First, how many dynamic typing-related practices appear in Python? Second, why are they introduced into systems by developers? For example, they are introduced for specific maintenance activities. Third, what is the relationship between the practice and the program quality? Fourth, faced with the bugs produced from dynamic typing-related practices, how do developers fix such bugs? In order to answer these questions, we combine quantitative study and qualitative study. For quantitative study, we select 9 publicly available Python systems, which are famous systems and are in different domains. In each system, we use the detection tool to detect dynamic typing practices. We also mine the maintenance history in GitHub for each system. Especially, we automatically identify the methods which are affected by bugs in history. For qualitative study, we manually inspect the introducing intents of 353 cases for underlying why dynamic typing practices are used by developers. We also manually analyze 200 bugs which are related with dynamic typing related practices for understanding why they lead to bugs. More importantly, in order to further explain the research results, we conduct an interview. We have a discussion with 70 Python developers from GitHub to understand why they introduce dynamic typing related practices into the program and how they fix dynamic typing related bugs. Now let's see the result of each research question. The first question is, how many dynamic typing practices exist in Python code? This table presents the number of the practices detected in each system. You can find that these practices exist inconsistently in different systems. For example, in Ralph, the most common practice is dynamic attribute access, but in other systems, the most common one is inconsistent variable types. Generally, inconsistent variable types is the most common one, and inconsistent argument types and dynamic attribute deletion rarely appear in Python systems. The second question is, why developers use these dynamic typing-related practices? We analyzed the intents of 353 dynamic typing-related practice examples, and the intents are classified into 6 categories. Development means the example was created in early development stages. The asterisk means the example was used for regular maintenance tasks, such as adding a new feature, enhancing an existing feature, updating for a new platform, refactoring, and fixing bugs. The result shows that they are introduced by developers into systems mainly during early development phase, followed by adding new feature and feature enhancement. According to our survey response, developers say that they use them mainly for ensuring type losing, ensuring loose typing, and supporting different use cases. The third question is, what is the relationship between these practices and the program quality? In fact, we analyzed the exceptions reported in the bug reports of each system. We found that the most common exceptions in bug reports are type error and attribute error. This finding spells out a study of dynamic typing practices, which mainly produce type error and attribute error. In this experiment, we apply Fisher's exact test and the odds ratio to examine the association between dynamic typing-related practices and bugs. This table reports the result towards each type practice in each system. In summary, for most types of dynamic typing-related practices, they have a significant relationship with increased bugs. So we have discovered that dynamic typing-related practices have a positive relationship with bugs. In fact, according to our interview, the truth is many developers have encountered bugs from these practices. They explained that these practices are safe in most cases, but may induce maintenance issues in complex scenarios during evolution. So the last question is how to fix such bugs. In order to answer this question, we manually inspect 200 bugs, which are related with dynamic typing-related practices. We analyzed the root cause of each bug and summarized the bug fix strategies used by developers. Finally, we find that developers tend to add checks and to use exception handling to fix such bugs. You can find more findings and implications from the study in our paper. From our study results, we can get some hints about dynamic typing. First, we can find that some developers prefer static typing through type annotation because they think static typing benefits maintenance tasks. But most developers prefer dynamic typing because they believe dynamic typing speeds up development. Second, according to developers' feedback, they are aware that many dynamic typing practices are not the best solutions, but they still do this a lot. Our study suggests that dynamic typing practices are useful but dangerous. Finally, it requires refactoring tools for improving these practices. We have summarized the strategies to prevent or to fix underlying bugs. For example, making sufficient tests, or using exception handling to catch the potential exceptions, or annotating the type contract clearly in the documentation. Then it is straightforward to check if all cases are covered in code review. Finally, let me conclude the contribution. First, we introduced 6 types of potentially dangerous dynamic typing-related practices in Python. We also implemented a tool named PYDYPE to detect them. Based on this tool, we conduct an empirical study to analyze how widespread they are, why they are introduced into the systems, whether they are related with increased bugs, and how developers fix such bugs. The study results will benefit future research in these fields, including coding convention, language design, bug detection, and fixing. Thank you for watching. If you have any questions, please contact me by this email. Thank you.